Welcome back. This is an Aleks training video on finding half-life and rate constant from a graph of concentration versus time. Okay, they've given us a concentration that's dropping of the ammonium hydroxide at the beginning there. So let me show you a little closer. All right, so this is dropping, so that means it's being used up. Okay, that's one of the reactants, so it's going away, right? And so the first question they're going to ask is, what's the half-life of this reaction, right? How much time has gone on before half of the stuff is left? Okay, so a graph is easy to answer this question. It would be a little harder if you didn't have a graph, but you do have a graph, and so it's really easy. So let me pull it up one more time. Now, here is the original concentration. So this is all 0.1, 0.2, 0.3, 0.4, 0.5. So this is 1.2. So it starts off at 1.2. What's half of 1.2? What's half of 12? 6. So 0.6 is going to be half of 1.2. So you go down to half of it. So here's 1.2, go down to half, and bring a line over, and then bring a line down. This tells you the number of seconds that it takes at this curve for half of it to be remaining. So that's simple, simple, simple. So we want to go back to the first question. What is the half-life of the reaction? Okay, well, the half-life of the reaction is 2 seconds. Okay, because it takes 2 seconds to drop down to half at whatever this rate is. Okay. All right. The next question. Okay, the second question you're going to need a formula for, because there needs to be a relationship between the rate constant and the half-life. Right? So we know the half-life. We know the half-life is 2 seconds, and so I need to know what the K is, or what the constant is here, based upon the rate constant. So it's going to be K is the natural log of 2 over time to the 1/2. Okay, so time to the 1/2 is your half-life. We know the half-life is 2 seconds, so this is going to be the natural log of 2 over 2 seconds. Okay, so the LN button is on any calculator. It's the natural log. So I'm going to put 2 in the calculator. I'm going to hit the LN button and get 0.693, then divide by 2, and you're going to get K equals 0.3465739. Okay, and they're asking us to go to 2 significant digits, so that's going to be K is going to equal 0.35. And then what's my units? Well, my units is seconds here, 2 seconds, so it's going to be seconds to the -1. Okay. And then the last one is pretty simple. Predict the concentration of the stuff after 12 seconds have passed. The only thing you know is that every 2 seconds you're going to have half as much as you used to have. All right, so you could just take the original sample of 1.2 molar and divide by 2 however many times 2 seconds fits in 12. Okay, so 2 will go into 12 6 times. That means it's 6 half-lives. So you're going to take 1.2, which is the original concentration, divide by 2 equals 6 times. And that'll work. Or you can simply realize that what you're doing is taking it 2 to the 6th power. right? So it's 1.2, your molarity is 1.2, and you're dividing it by the half-life, which is 2 seconds, 6 times. So that's 2 to the 6. So 2 to the 6 is 64, and so you're actually dividing 1.2 divided by 64, and you're going to end up with 0.01875 molar, and we went around to 2 significant digits, so this is going to be 0.019 molar. Okay, so not as scary as you thought. You do have the formula that you have to write down. Make sure you put that in your notes in case you ask a question like this again. Thanks.